Hey guys, this is Kreuter and I'm back with a new video. So this time we'll talk once again about an amazing new Blender feature, which would be the voronoi cell fracturing tool, which was integrated in Blender just a few days ago in the new test build of Blender 2.64. So don't get irritated by this splash screen. I don't really know why it is here, but this is actually the 2.64 test build here. So to get it, this version of Blender, you have to go to download.blender.org /release/blender 2.64, so this here, and then download just the version for your operating system. Yeah, you should know which one you have to choose. But keep in mind that this will only be for the next few weeks, I think, because I think they're planning to release the final version of Blender 2.64 in August or so. So it will be outdated very soon, this link. So later you just have to go to blender.org, download, and just download the latest build. So you get Blender 2.64 or a newer one. So now we are here in our Blender 2.64 actually, not that 6.3. And yeah, the first thing that we have to do is to go to our user preferences and type in here cell, and then you will have here the add-on cell fracture. And of course, I think you very quickly want to see a demonstration of what this feature can do. So give me just a second and I will do a very quick demonstration of it. So just a very simple setup here. Of course, you can see already there are many settings here and it's actually really complicated. And yeah, I will just pause the recording for a second because this takes a while. Now about half a minute has passed and we can see on our second layer we have lots of pieces here from this object. And let me just hide this object. Okay, and as you can see these are actually really cool pieces that we generated out of this torus, and we can do really cool effects with them, and also they're already set up for simulation, so just add a plane under them, and as you can see very quick in the game engine it works really well. And also the problem you had with the object exploding in there, we don't have that anymore, so that was just a very quick demonstration of the features, and now we're going to have a look at the values and everything more in depth. So I'm going to just load a new scene here, and of course you have to activate that add-on. So go to cell and yeah, just activate that. And now, yeah, let's delete that too, we don't need that for now. And then here on the first layer, let's add the object that you want to fracture. And for now, let's leave this cube here as an example, and then just select it and click on cell fracture. And then you have all these settings here, which are really hard to understand. So for example, I wanted to upload this video a bit sooner, but it took me quite a while to understand what these ones up here were doing. So yeah, I'll try to explain as good as I can. But okay, now what this fracture system does is it gets information of points out of your settings here and tries to generate a cell around each point. So a point could be a vertex, as these ones here. So there are 8 vertices now here. So if you won't change anything here in the settings, you'd have 8 pieces later on. And as you can see, also the generated pieces are if you don't change anything on a layer, on the next layer after your object. And as you can see, as I said, we have 8 pieces now generated because there were 8 points here. Okay, so now I'll just delete what we generated here. Now you could also use particles as points. You can see here there are also particle settings. And also later on I will show you that too. The grease pencil, that's also a feature. But now let's try out to subdivide this one edge here. Now we have 9. I will call them points for now. 9 points, and now I generate that again without any special settings here. And then on the next layer you can see again we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces because there were 9 points. Okay. So that's what happens if you tell this the cell fracture to use its own words as point input for yeah, kind of. This is something I'm going to explain later on, and this is the next one. It can also use its own particles to as that point input. So let's create a particle system very quick with all the particles generated in the first frame. And let's don't overdo it because this can take quite a while to calculate. Let's do just 10 particles. So we have now, let's delete this one again. So we have 8 vertices and 10 particles. So together that would be 18 points. And now if we fracture that, you can see that here we have 18 objects. Because yeah, as you can see here, it uses as point source its own vertices and its own particle system. Now if you deselect that own words thing and there's only own particles left and you generate that, you can remember that we had 10 particles, and that means that there are now 10 objects. Okay. We could also do the same thing just with own words. So now there are 8 again of them. So that's that. And now there are for both of these child particles and child words. These one do that. For example, if we have a second object, let's do an icosphere. If we have a second object somewhere like here, for example, and this one is parented to the cube. You can do that with Control P, set parent to object, yeah, and then this one is parent to this cube, and then you can go to cell structure and tell this generator not to use its own words and also not its own particles, but it should use the words of child objects, so that means objects that are parented to the cube, which would be this sphere in this situation. So it would use the points of that object. And as you can see, of course, yeah, simply it used these points as an input. So I don't know how many points were that, 12. So there should be 12 objects now here. And as you can see, 12 objects again. So for each point which is used as an input here, one piece is generated. So I hope you understand that so far. Grease pencil is now a bit more complicated, but I'm going to tell you about that later on. Okay, but for now, let's have a look at the next value, the noise. So that's actually pretty simple. So I'll just show you a comparison between the two results. So I just generated it without noise and now with noise. Okay, so you can't see much difference for now, because there. Yeah. First of all, let me just change one thing in the setup. Sorry for that. I just don't want to have the particle system as an influence. So yeah. So this is our first result without noise. And now the next result with noise is this here. So we still have the same amount of objects, just with noise in it. So this is without noise, and this is with noise. Of course, a value of 1 in the noise setting is a lot, so you can't really see very good where the objects were, so it's not separated into very clean into 8 objects, but yeah, you can see it's still 8 objects and just with more noise. Now you can also have, yeah, just very quick, this here is the source limit value. It just so you don't have so you can't use too much input for the objects, because if you have 100,000 particles in a system, it just couldn't calculate all of it. That would take forever. You can say you only want to have 200 as a maximum of generated pieces, just like that. Okay, this is also something I want to talk later on about it. The next thing is this here. Now this is something like it subdivides. It reuses this tool. I'll just show you how it works. So if I set that to 1, really don't overdo it with this value, because that's, yeah, you can see every generated piece will be fractured once again after it's done. So now we have 4 times, no, actually, I don't know, 8 times, 4 times, whatever. We have much more pieces here because yeah, it just resubdivided everything we had. Okay, this video will be quite long, I think. Okay, but anyways, yeah, if you set that to 2, what happens is that it subdivides everything one more time, and then those smaller pieces again. So this takes already much longer to calculate, but you can see that it subdivides this really big pieces, and then those smaller ones are being subdivided again. So if you use a value here, like, I don't know, 100 or so, you could wait forever until it's done. The cool thing about it is still that Blender won't crash. I don't know, it didn't happen to me that Blender crashed yet, so it's running really stable and everything, even if you have really high values. So that's a really good point about this generator. Okay, so I'll pause the recording again for now. Blender is done with it, and you can see it generated quite a lot of pieces. Okay, now you don't, even if you use that what is it called, recursion tool, you don't you can also change the yeah, it's called here the likelihood of recursion, which means that you can change how many percent of the pieces that were generated in the first step will be resubdivided. So if I set a value of 0.5 here, you can see that only 50% of the big pieces will be resubdivided. So here 4 pieces not subdivided and 4 subdivided. So that's then, and then we have here these 5 settings. I wasn't able yet to get an example to work where you can really see what changes with them, but I think they changed the appearance where it gets subdivided again and where not. For example, these ones should do that if you say just 50% of the object should be resubdivided, you can say, for example, only those near to the cursor should be, and those away from it shouldn't. So the 50% around the cursor, or small, just the small ones rather than big ones, or the other way around, or just random where this. I think that one should work now. Let's see. Yeah, so no, it's actually the same. So here in this example, of course it should work somehow, but yeah, I couldn't get it to work. I also always get the same result, so that's a bit strange. That's just one of the things that I'm not quite familiar with it yet. Okay, now we also have here things like smooth, yeah, which one? Yeah, this one is another value that matters a lot. This is the margin between the pieces. If this is if it is 0, the simulation wouldn't work well. But to show you a bit better what it does, I'll just turn this up a bit, and as you can see, with this value a bit higher, the result looks like this. So the pieces have some space between them, and yeah, it's just how much space should be between these pieces. Yeah, the default value is really good for simulation, so that should be good. Also, you can change the material that should be used for the inner part for everything that's not visible now. So just create a second material here, a red one, to have a contrast, and this one green. Okay, so for now everything is green. Oops. And if we subdivide it and set that to 2, I hope that works now. I've actually never tried it out before. Okay. Yeah, okay. I set the value for 1 too high. I think it's the offset of the material. So if everything is set to material 1 and you set that to 1, it will make one step here in the material list to the next material. And if it would be 2, it would make 2 jumps to the third material, which doesn't exist right now. But yeah, as you can see, now everything inside has the material which comes one after the actual material. So everything inside has this one now. Okay. But now let's have a look at the next next one. Yeah, you can also change the mass now for all the pieces. Yeah, recenter is something you can do very easy later on with Control Alt. Yeah, Control Alt Shift C, I think. Yeah, but yeah, you can also do it here. Then here it automatically puts all the pieces on the next layer, but you can also change that here, set the layer which one you want it to be on, and yeah, things like that. Also put it into group right away and show the progress in real time. Yeah, things like that. Okay, now let's do work with the grease pencil input. So if you're familiar with Blender, you know that the grease pencil is actually just something like a string of points. So if I draw a line with the grease pencil, I just hit D and hold it. I held D down and clicked and drag the mouse so I get the line. But if you zoom in, you can see this actually 1 point here, 1 point here, 1 point here, and these points are connected together. And if you fracture that object now with grease pencil input, it uses each point here as an input, and as you can see, there are quite a lot of points, of course, and it will also generate all of these pieces now. And of course, you can also do less points. For example, if you select an object, that's more important, select it, and then you just draw a line. A line normally is just 2 points, one here and one here. And then you can use the grid pencil input. It should be just 2 pieces. And as you can see, just 2 pieces here and here. And that's all. Yeah, so that's that. It's just one more way to use the input. And yeah, this is, I think I didn't mention that before. If you have a particle system in another object and you parent that object to this one, it can also use the particles of child objects as points, as I decided to call them these points. Yeah, and yeah, also the next very important thing is this scale. For example, if you want to create something like wood, so this is our example here, just this. Let's say this is wood. And now we fracture that and we set the scale along the z-axis to 0.05. And we set this to 1, and yeah, I think I should have also used noise. Like, pause the recording, and now yeah, I should have used a bit noise to make it more interesting. It doesn't really work without noise, that wood effect. And yeah, like this. And let's pause the recording again for a second. And now you can see all these pieces are longer as they usually are, because it's scaled everything. Of course, if it would be wood, you'd have to scale it even more, so I think 0.02 would be better, but I just choose a value that I thought would work. But that's that. Okay, that's actually it for these values here. Just one more thing that I want to show you. If you, let's do, just very quick, a simple scene. Yeah. Generated very quick some pieces here, and let's say in the simulation everything works fine for now. So you can see it's just the collisions of the ground. Let's change that very quick. Go to Blender Game here and change the collisions to box and make that to a box, and now pieces won't go through that object anymore. Okay, now everything works fine, but now let's say we want all the pieces in this corner to stick together. So select the ones you want to stick together and then hit Control J. Yeah, just shift right click on one of the objects to get an active object. So Control J to join these objects, so everything is now in one object. But now if you run the simulation, this breaks before it collides with the ground, because they're wrong collisions. You have to select this object and change the collision bounds to triangle mesh, and now it should actually work. And as you can see, it works fine. And you can still see that these pieces, yeah, they stick together and won't fall apart. So that's, for example, for walls, pretty cool. Or also if you want all the ones on top and all the ones on bottom to stick together, it's also very easy to do so. Okay, for example like this. Now all the ones on top stick together. Yeah, works pretty good. And also, yeah, something I found was really cool. Yeah, if you use an icosphere, this is really the fastest way to generate something like a football or so. An icosphere with a subdivision of 2, go to this, use its own words, and actually you don't have to change anything, but now generate it, and you will see on the next layer what you have is pretty much a football, because now you have those shapes with 6 corners and those with 5. I just thought that was really cool that this happens. You can join all of them together and delete all the vertices in the middle, and there you have it. Football, something like that. Yeah, whatever. That was one example for what else you can use this for. Another one that's really cool is if you fracture an object and you get many pieces that look like similar to stones, actually, random looking objects. Where is it? Yeah, here we have it. You can. What works pretty good is if you use the bevel modifier, you can even make that effect stronger. Add to one object the bevel modifier, select all of them with this as the active object, Control L, make links to modifier, and now you have a lot of objects which look similar to stones. And now you can do a particle system, create a particle system on a separate object. Yeah. And first of all, select all of these pieces and group them with Control G. And then, of course, this is now more advanced, so this is not a step-by-step tutorial on this. Okay, but you can say it should render, the particles should be rendered as one object out of the group. This one, is it this one? Yeah. Let's make them bigger, and yeah, you can also say pick them randomly, pick random, and as you can see, you can withdraw now with stones. You can also have collision objects like this, and then spread them on a plane. Yeah, these are just some examples for what you could use it for, and that show that is really useful there too. And I think that's everything I wanted to tell you in this video. I hope you enjoyed watching it, and I hope I will see you again in the next video. See you soon. Bye.